Okay, so the next step, step 8, is to pay attention to what units your variables are in. Make sure you know what unit each numeric variable is being measured in. Again, so you don't crash a spaceship. We're going to use our example here of income, how much income each household has from various sources. And you can see that the unit is conveniently included right here in the cell with the number, which is a great way to collect data. So this is in Papua New Guinea Kina. This is either missing or not applicable. This one's in Papua New Guinea Kina. This one here, though, is in US dollars. And you can see that there's a few more that are in US dollars. So the first thing that we need to do is separate the number from the units so that you can analyze the number as a number at a later date. So you'll want to, again, make a copy of it and then insert so that you don't mess it up. Then we're going to insert a column so we have space. And we're going to use the same old text to column feature to separate the number from the unit. So that's under the data tab, text to columns. And this time you can see that they are separated by a space. So we're going to put a space in there, and that works quite well. And yes, great. So this is income amount, and this is income amount units. So now when I go to analyze it, I'll be able to see that this 50 here is in US dollars, not in Papua New Guinea Kina. If you want to analyze them as one standardized rate, which is a great idea, you could do a new variable called income and then a standardized rate, and then we'll standardize it to Papua New Guinea, since this is going to be Papua New Guinea. And then anything that is already in Papua New Guinea Kina, you can keep as is. You can just copy and paste that formula and to keep all the Papua New Guinea units. And then to convert, you would need to do some research, find the conversion rate for the proper date of US dollars to Papua New Guinea Kina. I'm not exactly sure what it is, but it's probably around maybe 2.2, I'm just guessing. And Excel is going to tell you that this formula is different, and that's okay because you want that formula to be different, so that's actually a very good sign. And then you can copy and paste it into all the places where you have the US dollar currency. So now you have a new variable that is standardized all to the same unit. There are faster ways to do this in programming languages, or there's even faster kind of formula use in Excel, but I'm teaching you kind of the basic step 1 way to standardize things. Okay, so for our last two steps, steps 9 and 10, we are going to look at the checking for impossible values and unlikely values. We're going to use an example of the number of coffee trees. So this is a record of the number of coffee trees that each household owns. And we can see that there are a wide range of values. Now you can do this in Excel or you can do this in Tableau. It really depends on what your preference is. And of course, there's many different ways to do it. The first thing we'll do is we will look at the number of coffee trees as a simple scatter plot, which is kind of like a baby version of a histogram. It works, it does the job, and it certainly allows us to see immediately that we have one number here in the number of coffee trees variable that is very, very radically different than the rest of them. And that number is so big, we have to decide whether that is impossible, or unlikely. And if we look down here at the row that huge number of coffee trees is in, they have a fairly average income. They have 3 coffee gardens, and they have way more coffee trees than you could possibly have in 3 gardens. So this number is not unlikely, it is impossible. So this number is not an outlier. This number is actually incorrect. This is a measurement error or a data entry error. So now you need to make a decision of what you're going to do. Best case scenario, if it's possible, is to go back and find out what that real number is. If it's not possible to do that, then you need to change that to missing for now. And that is what to do with an impossible value. So now that we've changed that to take out the major outlier, let's again look at our little kind of handmade histogram. And again, we're looking at the number of coffee trees, and there's a number here that is higher than the rest, but not orders of magnitude higher. That still might be a real value. Let's, as our next step, sort the data again so we can see the range. Again, there's ways to do this visually, there's ways to do this in Tableau, but let's just do it right now, quick and dirty in Excel. So we have a null, which we just changed, and then this is the next very big number. We want to know if this number is so big that it's impossible or it's just unlikely. So they have 4 coffee gardens and they're making about 1,500 kina. And then related, the next one down has about half the number of coffee trees and about half the number of coffee gardens and a fifth of the income. So this number is not impossible. This is in the range of these other numbers that we see here. This is not an impossible number. It is an unlikely number. That's a lot of trees, especially for this part of the world. So what you'd want to do is you'd want to flag that for yourself and talk to somebody who knows. So either go back and talk to the people who live in that village, because of course we have the information of what village they're in, and we can go back and double check how many trees do they actually have and make adjustments. Or we can leave it as is, because often outliers, which are unlikely but not impossible values that are measured correctly, these outliers are often the source of really interesting parts of your story. But you need to know whether they're an outlier because of measurement error, data entry, or real genuine outliers. Again, each time you make any of these changes, so when we changed this giant number to null, and when we highlighted these numbers as numbers that we should check into to make sure that they are in fact correct, you have to write that down in wherever you're taking your data cleaning notes so that everything is reproducible, so that anybody could go back to the very first version of the raw data, do the very same steps that you're doing, and get to your analysis, get to your results. That's how to make reproducible research possible, even when you're using Excel and or Tableau, which are not kind of programming languages that leave behind a trail of a script. So these are the 10 basic steps of data cleaning, and feel free